We now discuss the solutions of the problems related to counting under the section Algebra. Such questions which have appeared in the TS SET and AP SET examinations. And these problems are suitable for JL, DL, AP SET and CSIR NET aspirants also. Now first, you see the syllabus that is meant for TS SET and AP SET under Algebra. In that, the first section consisting of combinatorics, namely counting, consisting of permutations, combinations, pigeonhole principle, inclusion-exclusion principle and derangements. All these items consists of problems on counting under this algebra. And a student of mine expressed difficulty in solving problems related to counting. That is because that you have not read these things under counting properly. And if you have studied discrete mathematics, these items will be present. That is, the problems related to counting will be many there. So I have noted down his difficulty, therefore, and I have decided to devote one video consisting of 3 questions, 2 questions of TS SET and 1 question of AP SET on counting. So I will now 1 question of TS SET 2019, 1 question of TS SET 2023 March and 1 question of AP SET 2024 related to counting we will be discussing in this video. Right. We first go to a question that has come in TS SET 2019, question number 66, and with this question ID. And from algebra, it is related to counting. A group of mn people are to be arranged in m teams with each n players. So m teams to be arranged in m teams, each n players. So that means the total number of people will be mn. If teams do not have names, that means we do not recognize what team it is. So first team, second team, third team, mth team, m, like that you will have. But even the first is also not known. So they are not numbered and they don't have names at all. Then the number of ways in which it could be done is, we are given 4 options. First option is mn factorial by n factorial to the power of m into m factorial. And the second option is mn choose n. It is the same as mn cn, like that. So now let's now discuss the solution of the problem in detail. We have mn players. First, what is that we do? Our problem is to arrange these mn players into m teams with each team containing n players. So what do we do first? First, choose n players from mn players. In how many ways you can do that? This can be done mn cn ways. Agreed. So n players you have already chosen. So how many players are remaining? mn minus n. So that is mn cn teams can be formed by choosing n players, right? That is the above thing. Now having chosen n players, we have how many remaining? mn minus n, that is m minus 1 into n players. Now what do? from these m minus 1 into n players, we choose n players again. Now choose n players from m minus 1 times n players. This can be done in m minus 1 times n Cn ways. So far how many players you have chosen? First n players, second time n players. In all 2n players you have already chosen. Right. Having chosen 2n players, the next one will be the number of teams that can be formed is m minus 1. From that one you will subtract m minus 2n Cn. Then n. 3n players you have chosen, like that. You continue. So, having chosen 2n players, the number of teams that can be formed is m minus 2n Cn. Now, at the end, m minus 1 into n players will be there. This is the last step. The number of teams that can be formed is, out of that n players you have to choose. That is m minus 1 times n. mn minus m minus 1 times n. Cn. This is m minus m. 0 minus plus 1 time n Cn. So this is the last team. This is the last team. Right. So the number of teams that can be formed by the product rule. Why are you using product rule? The total task is to be divided into m tasks. First task choosing n, second task having choosing n, so on and so forth. So this is one after the other, the tasks are performed. Therefore we will use the product rule of counting. In the first place, the number of teams is mn Cn. First selection. Second, m minus 1 n Cn and m minus 2 n Cn, and so on and so forth. At the end we will have 1 times n Cn. So this is the m teams are formed, and we will use the product rule of counting. So we have to multiply. So multiply one after the other. So this is the one. Now you write down the meanings of NCR. What is the meaning of NCR? NCR is equal to n factorial by r factorial into n minus r factorial. So mn will be equal to mn factorial by n factorial into mn minus n factorial. And what will be m minus 1 times n Cn? So the m minus 1 times n factorial by n factorial into m minus 1 times n minus n. So like that you go on doing it and you will get this one. Now look at them carefully. There are some cancellations that are there. So this cancels with this one. Agreed. And you can also see this cancels with this one. They are one and the same. And this one cancels the next one, etc., etc. The next one cancels 2n. At the end, this n factorial cancels with this n factorial. After the cancellations, in the numerator, you will have mn factorial. In the denominator, n factorial into n factorial into n factorial into etc. n factorial. How many ways? This is also n factorial, n factorial, n factorial, n factorial, n factorial. M ways. M selections are there. So n factorial to the power of m will be there. So, right, this is the one. Now, how the teams are not numbered or teams are not given any names. So that means in these the teams are permuted and written duplicated also. Therefore, you have to divide by m factorial. That's because this now given the teams do not have names or numbers, then the number of ways in which it could be done is that you have to cut down those which are repeated. So in this m factorial times these are included. Therefore, we have to divide. So mn factorial by m factorial into n factorial to the power of m. You have to understand this carefully. Let's look at our options. So our answer tallies with option 1. Therefore, the answer to this question is option 1. So that is the detailed discussion of this problem, and we will move to the next question. This is the question which has appeared in TS SET 2023 March, and this is question number 66, bearing the question ID this one. The given question is the number of integral solutions of the following equation x1 plus x2 plus x3 plus x4 is equal to 30, with the constraints or conditions x1 greater than or equal to 2, x2 greater than or equal to 3, x3 greater than or equal to -5, and x4 greater than or equal to 8. You have to find the integral solutions. Integral, that means solutions which are integers of this equation subject to these constraints. And you are given these options. 4 options are given. Here, the bracket 33 means this is 33, choose 3. That is the same as 33C3. So accordingly, you have to read this one. Right. Solution. To find the number of integral solutions of the equation x1 plus x2 plus x3 plus x4 is equal to 30, subject to the constraints x1 greater than or equal to 2, x2 greater than or equal to 3, x3 greater than or equal to -5, and x4 greater than or equal to 8. Now, we have formulae for finding integral solutions of such equations where the constraints are positive. x1, x2, x3, x4 are positive. There is one formula for that. And if the constraints are x1, x2, x3, x4 are non-negative integers, there are 2 formulae that are available to that. So what I will do is I will go for non-negative integer solutions. So for that I will put y1 is equal to x1 minus 2. When x1 greater than 2, then y1 will be greater than or equal to 0. That means y1 will be non-negative integer. y2 is x2 minus 3, and y3 is x3 plus 5, and y4 is x4 minus 8. Then what will happen? For subject to this given constraints, the new constraints will be yi greater than or equal to 0 for all I 1, 2, 3, 4. That means non-negative integer solutions you are looking for the transformed equation in terms of y1, y2. So the transformed equation is, in the place of x1 we will write y1 plus 2, and in the place of x2 y2 plus 3, and y3 minus 5, y4 minus plus 8 is equal to 30. And simplifying, we will get y1 plus y2 plus y3 plus y4 is 30 minus 8, that is equal to 22, where yi's are integers and they are all greater than or equal to 0. For all I is equal to 1, 2, 3, 4, that means yi's are non-negative integer solutions. That means the given problem is now reduced to find the number of non-negative integral solutions of this equation y1 plus y2 plus y3 plus y4 is equal to 22. You are looking for the number of non-negative integral solutions. That is, it is equivalent to find the number of ways of distributing n is equal to 22 identical objects into R is equal to 4 groups. 4 groups. If empty groups are allowed. What is the meaning of empty groups are allowed? That means a group can be empty. That means the number of elements in that group can be 0. That means y1 can be 0, y2 can be 0. That is why it is taken yi greater than or equal to 0. So is equal to 0 will correspond to empty groups. So for that the formula is, it is given by n plus r minus 1 by 1. Choose r minus 1. That is n plus r minus 1 c r minus 1. That is n is equal to 22, r is equal to 4. You substitute and you will get the answer 25C3. So let's look at our options. In the options, this 25C3 appears against option 3. Therefore, the answer to this question is option 3. So that is the detailed solution of this question. And this is basically a counting methods. So you can also think of finding positive integral solutions of the equations x1 plus x2 plus etc. xk is equal to n, like that. And then the formula will be n minus 1 c r minus 1. And practice such questions. Now I will show you the next question from AP SET 2024. It's again counting and the question number is 31. Let's read the question. If 8 different letters are placed in 8 addressed envelopes meant for them, one for each letter at random. That means you want to place 8 different letters in 8 addressed envelopes at random. Then the number of ways, the constraint is coming, the number of ways in which exactly 3 letters go into correctly addressed envelopes. That means you have to find out the number of ways in which exactly 3 letters will go into correctly addressed envelopes is. That number you have to find. We are given 4 options. These are the 4 options. And if you want a solution for that, you need the concept of a derangement, which I have already told you, and you need the knowledge of derangement to solve this one. So the concept of derangement is needed. So I will explain to you briefly what is a derangement. Derangement. A derangement is a permutation of finite number of objects that leaves no object in its original position. This means it's a permutation of finite number of objects that leaves no object in its original position. And the derangements of the set 1, 2, 3, you have to place derangements as 2, 3, 1. So in the first place 2 is there, in the second place 3 is there, in the third place 1 is there. So no element is placed in its original position. So also 3, 1, 2. For 1, 3. For 2, 1. For 3, 2. No element is placed in its original position. So in the case of 3 elements, these are the only 2 derangements. So if you put the number of derangements on n letters is dn, then d3 is 2. And suppose you talk about 4 letters. 2, 1, 4, 3. It is a derangement because first place 2, second place 1, third place 4, fourth place 3. So no element is in its original position. So also 3, 1, 4, 2. Yes. And 3, 4, 1, 2. Yes. These are the sum of the derangements in the case of 4 letters. So etc. I said these are not the only 3 derangements. In the case of 4 letters, there are many. How many is the question? So how many means you want a formula for a dn. Dn is the number of derangements in the case of n letters. A formula for n greater than or equal to 1, the number dn, d suffix n, of arrangements of 1 to n is given by this formula. Dn is equal to n factorial into sigma k is equal to 0 to n minus 1 to the power of k by k factorial. And this formula can be derived using the principle of inclusion and exclusion. This is the number of derangements. As an example, I will calculate d5. So d5 will be equal to 5 factorial into sigma k is equal to 0 to 5 minus 1 to the power of k by k factorial. So expand this 5 factorial into 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. Right. And 1 minus 1 by 1 factorial cancels, and you will have 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial multiplied by 5 factorial, and you have to simplify. So taken the LCM is 5 factorial. So you get 3 into 4 into 5, and here 4 into 5, here you will get 5, here you will get minus 1. So 5 factorial cancels, and you will get 60 minus 20 plus 5 minus 1. When you simplify, you will get 44. So D5 answer is 44. And this is required for me. That is why this example I have calculated here. Let's get back to that question of AP SET 2024 on counting, which bears the question number 31. This is the question. So we are given 8 different letters, and those 8 different letters are to be placed in 8 addressed envelopes at random. And you have to find out the number of ways in which exactly 3 letters go into correctly addressed envelopes. So to find the number, this is a task. The task is placing 3 letters into correctly addressed envelopes. This task can be divided into 2 tasks. First task is first send these 3 letters into correctly addressed envelopes. Then the second task is the remaining 8 minus 3, 5 letters are to be placed in these envelopes such that no letter is placed into the correctly addressed envelope. Right. So that means exactly 3 letters are to be kept in correctly addressed envelopes. That's the first task. And in the case of the remaining 5 letters, no letter will go into correctly addressed envelopes. The first task is to put 3 letters into the correctly addressed envelopes. Out of 8 letters, this is to be done. In how many ways you can do that? 8C3 multiplied by is a product rule you have to apply, because it is the first task followed by the second task. The second task, the remaining 5 letters, no letter will go into correctly addressed envelope. That means D5, the number of derangements of 5. So the required number will be given by 8C3 for the first task multiplied by, for the second task, the remaining 5 letters, no letter will go into correctly addressed envelopes. That means D5, the derangements, number of the derangements on 5. That's equal to 8C3 is 8 into 7 into 6 by 1 into 2 into 3 multiplied by D5. Where D5 we have already calculated, and that is equal to 44. So this is, when you simplify, it is 56 into D5 is 44. When you multiply, you will get 2464, and that is the option A. So the answer to this question is option A. Right. So those are the 3 questions that I wanted to show you. under the section counting and concentrate on this section, and it is in one way it is an easy section, and learn the formulae, learn some of the questions from that. Then you will be able to answer questions that are coming from counting. You may not feel difficulty. So that is the detailed discussion of the solutions of the 3 problems chosen from the TS SET and AP SET examinations related to counting. If you like my videos, please like, share and subscribe. I wish you all the best. Thank you.